Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier from 2024. Question number 4, which is on the topic of energy. A drone is a miniature aircraft that has a remote control. An inventor designed a battery-powered drone. The inventor tested what would happen if the battery runs out of charge during a flight. Figure 5 shows the inventor about to launch the drone. After the drone was launched, it moved at a constant speed and gained height. The thermal stores of energy of the drone increased. Describe two other changes to the energy stores of the drone as it moved at a constant speed and gained height. Actually, this is the second question they have asked about energy transfers or energy stores. So, what are the changes to the energy stores? Well, obviously the battery is going to die, so you could say the type of energy in a battery is chemical energy. Chemical energy store of the battery decreases. Now, because it gained height, you could say height is linked to gravitational potential energy. So, gravitational potential energy of the drone increases. Now, because it's at constant speed, we don't have to say anything about that. Next part, when the drone reached a height of 840 meters, the motor was switched off. The drone was switched back on after a short time, when the drone had fallen to a lower height above the ground. The change in gravitational potential energy of the drone during the fall to its lower height was 3,920 joules. That's the height. Let's mark this. The mass of the drone is 2.5 kilogram. That's actually a heavy drone. Gravitational field strength is 9.8. Calculate the height above the ground of the drone when the motor was switched back on. Use the physics equation sheet for 4 marks. Now, the equation is gravitational potential energy. Now, you won't find on the equation sheet as GPE. You would actually find it as capital E for energy and P for potential, right? Equals mgh, mass, gravitational field strength, and height. So let's substitute the numbers. So the change in gravitational potential energy was 3,920 equals the mass is 2.5 multiplied by 9.8 multiplied by the height. Rearranging the equation, height equals 3,920 divided by 2.5 times 9.8. That gives me a height of 160 meters. Now, remember at the start they said the drone reached a height of 840 meters, which means what was the height above the ground? You have to take away this 160 from 840. So 840 minus 160 is equal to 680. 180 meters. 680. When the motor was switched off, the kinetic energy of the drone was 150 joules. So KE is 150 joules. Calculate the maximum possible speed, which is V, of the drone when the motor was switched off. Use the equation sheet. So again, for kinetic energy, you're going to find in the equation sheet as EK for kinetic equals half mv squared. So half is 0.5. Let's say the kinetic energy is 150, so let's put 150 there. Sorry, I made a mistake there. Now, before I can write this, there's a reason why it's a 5-mark question. It's not just simply kinetic energy equation, right? I can't use 150 joules. Now, when the motor was switched off, the kinetic energy of the drone is 150 joules. We have to use that number. But remember, when in the previous question, they've said here, the change in gravitational potential energy of the drone during the fall is 3920 joules. That change in gravitational potential energy, because it's falling, it would have changed to kinetic energy. So you'll have to add this 3920 joules. So 3920 plus the 150, this is the kinetic energy gained due to the motor working. So that adds up to 4070 joules. That's the maximum kinetic energy. 4070 multiplied by 2.5 times V squared. So this gives you a mark. Substitution gives you a mark. Rearranging the equation, V equals, because it's squared, we have to find the square root of it. 4070 divided by 0.5 times 2.5. That gives me an overall value of 57.06 meters per second. You can round it off to 2 decimal places if you want to, and say it's 57 meters per kilometers per second. Oh, no, sorry. They want it in kilometers per second. So that I need to change it. So that's another, wow. Okay. So that's 57.06 meters per second. Now, if it's 57, I'll have to divide this by 1000 to get it into kilometers per second, which will be 0.057 kilometers per second. So 0.057. That brings us to the end of question number 4, and I will see you in the next question number 5.